Hi everybody. In this video, we will explore the subject of Gradle tasks, the ways to create it and how we can run it. So, what is Gradle task? First, we need to understand what Gradle is and how Gradle run builds. As I said in the previous videos, Gradle is a build tool, and to run builds, it uses snippets of code. Those snippets are called tasks. I will take it furthermore and say that Gradle is an orchestrator of tasks. If Gradle is an orchestrator, how does it know when to run a task? Tasks can have dependencies on another task and can be independent. The dependency is controlled when configuring the task's properties, like depends on and must run after. When executing a build, Gradle creates task graph to map all tasks and put them in order of execution. The task graph creation is done in the second phase called configuration. There are two types of tasks: actionable tasks and lifecycle tasks. Actionable tasks refer to all tasks that have action in them, like copy, zip, and compile. The lifecycle means that it is a task that have no action. Instead, it calls to other tasks. Much of Gradle's functionality is delivered via plugins. By adding a plugin to a project, the tasks that exist in the plugins are added to the project. For instance, the Java plugin contains tasks like compile Java, process resources, and jar, which are actionable tasks. And to run a compilation on a Java source code, Java plugin has a lifecycle task named build that calls those actionable tasks, which bind them into a full build flow. Let's see it in action. We'll open the terminal and navigate to our project. Now let's run a command to see the list of task dependencies. So the task that we want to see is the build lifecycle task. To do it, we'll call the Gradle W script, specify the task that we want to see, which is build of the core project, and we'll add the switch, which is dry run. Running it will list all the tasks that build task has a dependency on them. The command run recursively, so the listed tasks are descendant dependencies. Let's maximize the window to see it more clearly. You see that the build task depends on check. Check is also a lifecycle task that depends on test, which is an actionable task, and so on. Another way to see the task's dependency tree is to use an existing plugin. The task tree plugin, to which I added a link in the description of this video, can fulfill this need. To use it, we'll add it to the build script of this solution. Right-click on the Explorer view and select New File. Rename the file to buildgradle.kts and click OK. We'll add a plugin closure, and we'll add the Java plugin, which is a generic plugin for all Java projects. Then add this plugin in the plugins closure. We'll use the latest version, which is 2.1.1. So after adding this to the solution, save it and then in the terminal execute the task, calling Gradle wrapper and adding the task that you want to view, ending with calling to the plugin's task, which is task tree. Let's run it and you can see the task core build. See, it depends on core assemble and core check. Check depends on test and so on, seeing the entire task dependency as a tree. Creating a task can be done in a couple of ways. The easy way is to write it in a project build script using Kotlin. These tasks are local to the project of the build script. Next, you can add them to the build script of the solution. This gives you the ability to register the task in the project of the solution. The more robust and complete way is to write it in the build project using Kotlin and also Java. From there, it can be registered in the solutions projects and potentially be usable in other solutions as well. Let's create a simple task and we'll print hello world. So let's start by typing tasks, which is a property of the project, and call the register method. It gets a string parameter, which is the name of the task, and create the body. And the action will print hello world. Now that we've created a task and the task exists, now we'll try calling directly to the task. As you can see, the task is registered in the core project, and you see the output which came from the hello task of the core project. Now let's create the same task, but the goal is to use it in other projects. So we want to create it in the solution build script to be available in all projects, and then register it in the project that need to consume it. Next, we need to create a task. We can cut it from the core project and paste it here. Now the task is registered in the solution, but we need it in the projects. To do it, we'll use the subproject property of the solution and call the for each method that loop through all the items in a set objects. In this case, they are the projects. Move the task inside the for each closure to use every item Kotlin as a keyword it that holds the item in every iteration. To summarize, we are looping through the project of the solution, and for every one we register the task hello. Let's save all the changes and run the hello task again. You can see that the build is complete successfully and the task run under the core project. To take it to the next level in efficiency, let's create this task in the build logic project and then inherit it and use it in the solutions projects. To make it more interesting, we'll use the Gradle API and implement in Java language. To start, create a Java class in the build logic project. To make it more neat, we'll create a directory which all the Java classes will be. Let's name it Gradle tasks. Next, let's create the class itself. We'll call it Hello World Task. So the class is created. Let's add the package declaration. So the package is com.fastSQA.build.Gradle tasks. So let's add the import declarations and extends our class to default task. Let's import also the task action, which is an annotation that identifies a method as the action of the task. For the class to be recognized as a Gradle task, we need to extend the default task. Now let's create the task's action method. Call the annotation task action and create the method. The name of the method is irrelevant, so we'll use execute, but the function signature should be parameterless function with void return. In the body, let's add system out and print hello world. Now that we have the task, we need to add the task to the projects. Now that we've created the task and the task exists, let's run a build. Now that we've created a task, we need to register it. There are 4 ways to register, and we will view them all. Let's implement the 4 options. The first way is to register it in the build script of the project, which means that for every project that we want to use this task, we need to apply this method. This gives us flexibility in choosing which project we want to add this task. The downside is that you need to register each project separately. Let's start by opening the build script of the solution and delete the task that we registered. Run a build to verify that the task is removed. Open the build script of the core project and we'll add a registration to the task that we created. So the command is tasks.register, and now we'll use the generic version of the method and add angle brackets and enter the fully qualified name of the task. To do so, let's open the task and copy the package name and the class name. Return to the build script and paste it in the angle brackets. And then, as previous, we'll pass the name of the task. Open the terminal and run the Hello World task. As you can see, the build ran successfully, and you can see that the Hello World task is registered in the core project. The second way is to register it in the convention of the project. This gives us automatic registration for every project that uses this convention, but it denies us the opportunity to choose which project we want to register. Also, if we have multiple projects and multiple project conventions, we need to register in every convention that we want the task to be added. Open the build script of the core project and then cut the register command from it. Next, open the BuildLogic library convention script and paste it there. Open the terminal and run the Gradle Hello World task. You can see that the build is successful and the Hello World task runs in the core project. Third option is to create a new convention for the solution. Register the task there and add the convention to the solution build script. This means that the registration is automatic and done for all the projects in the solution using the subproject property as we did in the previous example. It also denies us from skipping registration for specific projects. Open the BuildLogic project and add a new convention for the solution. So we'll select a new file and rename it to com-fastSQA.solution-conventions. Open the build script of the solution. Cut the plugins section and move it to the new convention. Because the task tree plugin is not a standard plugin, and you can declare in a convention a plugin with specified version, we need to delete the version section and add dependency to the plugin with the specified version. We'll add a new section for repositories and add the Maven Central to it. Open the build script of the BuildLogic project and we'll add dependencies section. In it, we add implementation to the TreeTask plugin with the version that we want. Open the library convention, cut the register command from it, and paste it in the solution convention. We'll wrap it as previous with the subprojects method and for each loop, and add the it keyword. Let's review the changes. Created a new convention for the solution, moved the content of the build script of the solution to the new convention, modified the task tree plugin, removing the version and add a new dependencies in the build script of the BuildLogic project. We moved the register command from the library convention to the solution convention and modified it accordingly. To complete the changes and let the BuildLogic be visible to the solution, we need to add the convention to the build script of the solution. Let's open the build script of the solution and add a new plugin section. In it, we will call the solution convention from the BuildLogic. Let's run a new build and the Hello World task. As you can see, the build is successful and the Hello World task is registered in the core project. There is a fourth option, and the most flexible option is to use the convention of the solution like in the previous option, but to register in the build script of the solution. This gives us the flexibility to choose which project we want to register the task in. In general, the rule is to separate the build functionality from the project build logic. And so, the second and third options are breaking this rule, because we are registering the task in the build toolbox, and by doing that, we are forcing the task on the project's build logic. A crucial example is when we need to add a task and configure it to run after another task. If we use the second and third options, we are adding logic to the project's build that is imposed and hidden from them. It makes the build source less generic and the project's build logic less flexible. To implement it, all we need to do is open the solution convention, cut the register command from it, and then paste it in the build script of the solution. Let's run a new build and the Hello World task. As you can see, the build is successful and the Hello World task is registered in the core project. To summarize, we learned what is a Gradle task and how they created the build flow by dependency. We learned to view the task graph using various methods, and we created tasks using Kotlin and Java. The last section we learned ways to register tasks, and in each the pros and cons. Thank you for viewing my video, and I hope you find it helpful. If you do, please like and subscribe to my channel. Goodbye and have a productive day.